to introduce about the whole thing, especially for most of you it might be a new concept, right? Greenhouse gases, what it means, particularly working in people from departments from other areas not linked with science and technology. But I'm sure you all know, right? You all know that the whole it's a day-to-day now affairs, climate change or greenhouse gases. So almost even in the schools, this topic have been introduced, and it's being already in a large scale gaining importance, and at school level itself. So it becomes now more important than ever before, right? To understand what it means climate change, what it means greenhouse gases. Then we kind of get an idea how to, deal with that. So that is basic idea. And this particular, for today's workshop, which you might have seen the program, I think very well structured, starting from the idea of getting an outline of climate change or greenhouse gases. So my task have been now assigned to so-called demystify this, what it means climate change or greenhouse gases. So I will try to introduce mainly key concepts, as you already see in this first picture, right? 4 of this vertical picture. I'm sure you must be able to already guess what it means, the first picture here. As most of you know, it's just representing the drought, extreme drought. And then comes obviously the forest fires. And this is the third picture. You can guess it's representing the glacier. So, and then the fourth, emissions. So the implication of these 4 in general, just you can already start imagining what it means for global context, right? So I just want to also bring you some theories, if you understand what it means, some definitions of climate change and greenhouse gases, then I think it would make easier for the rest of the day, the lectures, what you can also understand from measurements and all those following this lecture. So to start with, what it means greenhouse gases. So the term actually, maybe you are aware of this term already, greenhouse gases, but sometimes especially for the new people, from all of the department, so you must be aware of what it means greenhouse. I think by definition greenhouse, the term itself, it's what is greenhouse and what is linked with the gases and how it is linked with the global warming. So greenhouse simply means, by definition, a typical dictionary definition, you all know, basically a chamber or the construction which we use it for growing plants, right? Greenhouse. But what it means greenhouse affect, how it kind of linked with the global context or earth like environment. I will come to that topic a little bit later. Okay, so like I said, of course, if the organizer would like to share this slide later, I would like to share these slides for those who want to understand particularly also the context. So basically the greenhouse gases, they are very crucial for Earth. So as soon as we hear of what it means greenhouse, it's not actually, should not be alarming in the context that we have to see in different perspectives. Similarly, climate change, what is the current status? I will come to that more detail in the later in my presentation. So as you see here, it's basically the gases that are naturally emitted from different sources, right? So I will also show you pictures on that. So are they good or bad? When we talk about climate change, it's directly linked to mostly of greenhouse gases, global warming, right? If right away if we see, oh, this is bad, we might think. But actually in nature, greenhouse gases are already in the process or emission are going on continuously, right? So it's actually in a way it's essential to keep a balance. So simply put, we need a balance of how the nature kind of works in a system. Similarly for greenhouse gases, obviously there should be a balance. That is the most key part, and anything going out of control or more than needed obviously is going to be detrimental, right? So that in that context, if we talk about greenhouse, that's what we are going to for this today's workshop for measurement and other thing, you will see more differently. So challenge is how we kind of manage it and also assess it. So this is something what I would say the most important part. What is the critical limit of greenhouse? What is actually existing in terms of natural also emissions? In simple terms, as you see in this graph, very easy to understand, right? Typically this greenhouse gas emission, this is for CO2, we have already seen in the first lecture, is keep increasing. That is the alarming situation. That is the main concern, right? So this graph is also depicting the same. So what are those gases? So for today's part, you will see the rest of the thing to bring you what it means greenhouse gases and different topics, or what types of gases exist. So there's not limited to only 7 of those, but there are many of greenhouse gases existing, more than this. So these are very general greenhouse gases, just for you to understand the 7 greenhouse gases under these Kyoto gases. So of those 7, you know, carbon dioxide, when we talk about mostly emission, we immediately get into like CO2, so that is the perception. And similarly methane, particularly from paddy field, right? And other gases. So I will get back to you in later slides. What is these different gases, how they are impacting our earth system, right? And why it makes a difference, what it makes different between carbon dioxide or methane in terms of impact on global warming. So this is the basic thing you have to understand in terms of particularly for today's later classes, right? So for you to get an idea, a picture, what is kind of making a difference over the time. This is already we have seen an example for CO2. If you see these greenhouse gases, particularly CO2 makes the bigger share globally, as you see in the chart, right? And rest of the gas, methane or N2, makes other part. So these are all generally called Montreal gases. Okay. And where does it come from, all these greenhouse gases? I think it's particularly important to know the sources. Of course, we know very well, like transport system, right here. So in generally, if you speak, we can divide the sources between natural sources and artificial source of greenhouses or human induced. So that is very clear. Basically CO2 from different sources, both nature and all this transport system, as you see in the picture. I think it doesn't need much of explanation. Just for you to know, it's very clear. Industrial emissions, particularly the whole of this emission, as we saw in the plenary lecture, whole of the emissions coming from after industrial revolution, and that is particularly also after this whole of this the invention of steam engine and rest of the times. So this is a little bit more detailed picture of climate model, how different things interact, different sources of greenhouse gases, how it is impacting the global temperature. Okay, now it's clear, like when we have so much emissions, and particularly like that we have seen energy, different energy sector, and then how they are at the end linked to greenhouse gases. This is also very important, because we can't overnight turn everything into solar, or like wind energy or solar, given that the fossil fuels have to be slowly reduced, but still if you see the percentage of the fuel is still a big part. And this is just a graph for you to know different budgets, starting from as you see here. If you see the gases are emitted and as well as brought back to the earth. So one is emission, another is the same gas is brought back to the earth. So it's not everything emitted stays there. So that should be very clearly understood for the people who are here for the first time to understand. So this is called flux. So once emitted, for example CO2, you all know how it comes back to the earth. Basically what we call as, for example, in terms of CO2, we call it carbon sequestration, right? Through the trees and various means, directly to the ocean. So many of those greenhouse gases, or most part of it, also comes back and also kind of sequestered into the soil itself. So that's how carbon emitted got back. So the remaining in the atmosphere makes it a big challenge to kind of having impact on the global warming. We will see more detail how these kind of greenhouse gases are impacting the global warming. So I think again this is a very clear graph, like to understand the CO2 and methane levels are consistently increasing, and here in the left hand side you see the ppm have reached around 380 to 400. But have you wondered how these kind of greenhouse gases existed some thousands of years back? Or when we talk about it's after industrial revolution, it's very clear it has been increasing drastically. But before that, since the time of the earth formation, have you any time wondered how the greenhouse gases or CO2 existed? So this is something also to know a little bit of history of Earth's formation and how the greenhouse gases, particularly the CO2, existed millions of years, and what is the current situation. Then you know better understanding of really is it CO2 is extremely high now, or was it previously during after Earth's formation, during ice age time, all that, is it higher than what it is now? So all that thing have to be I will come to that to get you an idea or perception of how the CO2 level or greenhouse gases existed thousands of years back. And what is the current status? Now we know little bit here, as you see in the graph, in terms of ppm. Okay. So at the end, the current scenario is mostly anthropogenic emissions. That is the most critical part of the whole thing. As we saw that greenhouse gases as such, if it is in a balance, it is a kind of necessity to give the earth system a stability. But if it kind of overshoots, if it is more than enough, then it becomes having a direct impact on global warming. So as it is clear that most of the fossil fuels in this picture, the emission keeps increasing. So I don't want to go into the detail of the data. Anyway, I can share you this. And before you get into the next kind of lectures on what is CO2 or CO2e, okay, we all know what is CO2, as I have shown, carbon dioxide as such, and CO2e, and that is also important to understand for the rest of the day, to understand the measurements, how they are going to measure different gases, and how what is the meaning of their impact on global warming. So in simple terms, as you see here, CO2 is can be, as I told, can be a natural sources or by anthropogenic, like all these fossil fuels. And of course, it's the most significant part compared to any other greenhouse gases. So now coming to the CO2e, right? So this is something what you need to understand. This is equivalent, CO2 equivalent kind of calculation, where you make it linking to global warming potential. So these kind of keywords, you need to understand what it means. So global warming potential. So one is the gas itself, and what kind of warming potential it has. So simply CO2 emitted doesn't mean like it's going to harm or it's not going to directly impact on global warming. Similarly, whatever the other gases like nitrous oxide, so each of those have different global warming potential. So that you have to understand. Okay, I hope this will also make you better link to the rest of the lectures or workshop for the workshop. So as you see here, CO2 metric allows for common ground to understand the impact of emitting. So that is basically that you need to understand what you want to measure it and calculate it. I'm sure the rest other lectures you will be shown how to calculate it. So I'm not going into details of the calculation right away, but I think that will be taken care of the other speakers. But just I want to kind of give you a little bit more insight into so-called global warming potential. As you see, basically the definition is it's a measure how much heat a greenhouse gas traps, right, up to a specific time horizon, and it's a value calculated over a long time, 20 years or 100 or 500 years scale. Global warming potential, so it simply means. So how to calculate and all you will see later in the day, right? And similarly, global warming potential also, as you see it, how it affects the energy balance. That is something also you will see later in the days, without much detail later. I just give an example here in terms of methane, as you see in the slide. So methane is having approximately 28-30 over 100 years time. 1 ton of methane has same warming effects as 28 to 36 tons. So it's very clear, right, which gas has more global warming potential, CO2 compared to CO2, obviously has methane. 1 ton of methane is having more global warming potential. So that you have to understand. And it's not about the quantity of the gas released, it's about also global warming potential. That is important. Okay. So as I said, it's basically important. I think also during the workshop you get an idea how you calculate it, each of these global warming potential, how you can calculate given 1 ton of CO2 or methane or nitrous oxide. So the calculation part will be taken care of the remaining. Okay, I'll skip that part on calculation. So coming to, as I said, Earth's history, right? So anyone have any idea of how the Earth's CO2 level existed some thousands of years back? Was it higher than now or lower? I think, was it higher sometimes, more than 400 ppm or 450? Was it always lower than now? Let's see. Okay, so basically you all know how many millions of years or billions, when was the Earth formed? Anybody from the back benches? Is it how many billions of years back Earth was formed? Was it 5 billion or any other number? Any guess? When was the Earth formed? How many billions of years? No idea, but we are still lying, standing on the Earth. I will come to that. So since the time of Earth's formation, doesn't matter whether in 5 billion or 4 billion, it has been formed, but still lot of changes have happened. As you know, ice ages, dinosaur ages, agriculture originated, all that. I will give you in one graph how it looked like thousands of years. So it's clear we had these so-called ice ages, and then how these kind of gases look like. Okay. So this is the graph I meant. Basically going back to, just don't worry about all this detailed data. Just quickly try to understand how the Earth's CO2. So basically these two sides. One is the temperature graph, and the right hand side it is a CO2 level. Okay. So you see years before, present. YBP is years before present. In fact, if you carefully see, it was always fluctuating. Okay. So this is something. For example, they have divided this graph into 6 eras compared to the current year, right? So if you go back to 500 millions of years back, it's clear like there have been always changes. One is the temperature, another right hand side you see CO2 level. So even before the time of dinosaurs, there have been always changes happening. If you see, there is actually the temperature and CO2 level more or less synchronized. The more CO2 here, more the temperature. So where we stand is here now, the current temperature, this is 0 now, like what we call it as, just we always talk about mean global temperature. So what is the mean global temperature right now? Don't consider the, when you go step outside, if you feel 30 degrees, Is it the mean global temperature? Somebody can tell here, mainly the new from other department. What is the global mean temperature? 15. Yeah. So, sir being from also our department from. So, it's 15 degrees, roughly between, sometime it's fluctuating, like 15, some estimate say 16 degrees, 15, 15.5. So, currently let's say average consensus is global mean temperature now is 15 degrees. So that is concerning the whole of the Earth's average temperature, right? So that is something you have to understand. So anything deviating from global mean temperature 15 degrees, that is something of concern, the increasing or decreasing. Okay. So when we talk about climate change or global warming, for those who are new to this topic, particularly you should understand this context of when we talk about global warming, compared to what it is, compared to some kind of baseline. You need to know the baseline. So global warming means compared to these 15 degrees, how much average increase going happening. And similarly, we talk about so-called critical limit of temperature of 1.5 degrees. Have you heard of this 1.5 degrees critical temperature? Have we reached that or not? Have we touched that 1.5 degrees average? Anyone? I will also bring that. So with the current trend, there is a forecast, several models. We might cross 1.5 degrees or 2 degrees or 4 degrees. And that's the different scenarios scientists predict what would be the disasters going to happen if we cross 1.5 degree. So basically, I just come back to that later. Basically, this graph, as you see here, at certain point of time, there have been always CO2 level was much also higher than current scenario. That was millions of years back. So there are a lot of events, volcanic eruption, many things was the reason, right? And particularly you see here, down here, the temperature was so high, so as also the CO2 level was so high compared to the current here, 400 ppm. But what is alarming, or what is the should be concerned? I mean, earlier also there was much higher CO2, but now we are much lesser even than the previous CO2. But what is the issue here? Can we just neglect it? Anyway, it is like nature. Anyway, it's happening over the millions of years, ups and downs. Can we just ignore it and go on? That is something we need to understand better. So the very idea is not about the quantity or the thing. It's also the impact it creates now to the earth, especially to the humans. That is something concerning. In the past, of course, if you see here, long back, not much of population like now. So the impact it creates to the current human population makes a big difference. And that we will see some example. You all know what it creates, that we have seen like so many impacts, sea level rise, population changes, right? So this is, I think this graph we already have seen, like increase in CO2. I'll just skip it. So coming back to the current situation, I'll walk through what is the, I think something I will skip it. So now greenhouse gases, we have seen CO2, methane, and we kind of saw the so-called global warming potential. But now comes what it means, impact of global average temperature, right? One is This 1.5 degrees we have been, as you see, from 19 after the industrial revolution, it has been consistently increasing, and the whole of the United Nations, all this effort, United Nations program wanted to keep it this average just below this 1.5 degree as much possible. But having this 1.5 degree, nearly 1.5 degree, we all see so much disaster now happening every year, like what European heat wave, also to India, so many heat waves, sea level rise, all these natural disaster, right? So the question about I asked you, right? Have we overshoot that 1.5 degree or not? Not yet. We are just reaching it. But there was again, but we are fast approaching, and now the latest thing is apparently we have just touched the 1.5 degrees. In 2024, we have touched 1.5 degree. So that means we are in a very, very critical limit when we touch the 1.5 degree and beyond. And now we'll see a different scenario as you see in the graph. When we work on in the past emissions, this is in gigatons. So we would have, with the current trend, this graph shows with the current trend, whatever the activity, human activity, we will be going with the current policy 2.5 to 2.9 degrees global average. That means we will be sure offshooting this 1.5 degrees, and naturally all these 2.2 to 2.5 degrees, is going to create a lot of disasters. That is something you need to understand, right? And if we take any measures, we will probably end up with around 2 degrees, 1.82 degrees, and we might you see it takes a long time to deal with that. And if we take really positive step, maybe we can restrict to 1.5 degree. That is something what you get a take-home message for the graph. Okay, so I just want to quickly skip some of the slides. Obviously, all these emission going to definitely create temperature because of shortage of time. I can understand. As you see, different sectors contributes to different emissions, right from energy, then agriculture, so all that. Okay. So with the current situation, this is the scenario from IPCC, Intergovernmental Panel on Climate Change, kind of authority for giving a report, annual report. CO2 is at the highest level and so on. Sea level rise is at the highest level. And that's what the latest figure shows. In 2024 already, we are just only in the March, have reached 1.5 degree or exceeds these 1.5 degrees that has been recorded. And again, already there is every year for the last 5 years or more. Okay, it's going to be okay. So something about carbon, how it is stored, how I already told you, right? How the carbon is emitted and brought back. So I'll skip some of the slide or mostly, and this also I have showed what it means greenhouse gases, which is trapped in a global context. In simple terms, if we don't get, if we have more of the greenhouse gases, the heat is not going out. Basically, this is something you have to understand. So it makes a blanket over the earth and heat is trapped. So in simple terms. Okay, and this impact of climate change on earth and us is very clear. You all are aware on an everyday basis. So I don't have to bring it more details because of also shortage of time. I can see Raghav giving a sign from there. All right. So I'll just come to a kind of take-home message. How why we need this kind of effort to deal with that. So future of humanity, and indeed all life on earth now depends on us, definitely, and this is something we need to understand why we have to have more of these kind of meetings in future, or more of thing to talk about greenhouse gases impact on global warming right from childhood. So with that message I just end my lecture.